To get the limit as x goes to 0 of x times cotan, if I want to first do a substitution, I can't because 0 is undefined, or cotan is undefined at x equals 0. So I won't be able to do that. So I'll need to do a little manipulation first. So we're going to change this to x times cosine of x over sine of x. I can't put in the 0 directly because I'll get a 0 for sine of x in the denominator, and that's a problem. But what I can do is use one of our limits that we already know, split this up a little differently. So I'm going to split up the limit as x goes to 0, and I'm going to switch the cosine x with the x. And I can do that because multiplication is commutative, so I can just switch the order. And now that I have x above the sine of x, then I know that limit, we already know that limit actually goes to 1. That was one of our bonus limits, but we can also think of it as this cosine x we'll have no problem with, but I can also think of this as the inverse of sine of x over x. Since limits follow the quotient rule, where I can just take I can kind of split this up into 3 pieces. I have the limit as x goes to 0 times the limit as x goes to 0 of 1 over the limit as x goes to 0 of sine of x over x. I can do that because of the product rule and the quotient rule of limits. It says that I can split that into pieces. So the limit of as x goes to 0 of cosine of x, I can use direct substitution, put in the 0 for x, and I get 1. And then the limit of 1 is just 1. And the limit of sine of x over x, we know is 1 from our original identity. So that gives me 1 times 1, which equals 1.